Breathe softly. Let the noise of the day fade like starlight, dissolving into the dark. Tonight, we drift beyond the boundaries of our familiar world, past the clouds, past the pull of the sun, into a quiet expanse, so vast it silences thought itself. Here, distances are not measured in miles, but in light, and time flows not in hours, but in eons. We begin a journey through our galactic home, the Milky Way, a spiral of 400 billion stars, turning gently in the dark sea of space. As we travel, we'll trace the stories of creation and motion, of light and gravity, of beginnings and endless return. Each chapter of the cosmos unfolds like a breath, calm, patient, eternal. So, settle in, let your thoughts drift outward, and allow curiosity to guide you. For even in sleep, the universe keeps turning, and there is beauty in simply knowing it. When we look up at the night sky, what we see feels peaceful. Stars scattered gently across the dark, like quiet embers left behind after creation. But behind that stillness lies motion and measure scales so vast that human language strains to contain them. To understand our galaxy, to even begin to speak of its size, we must first learn to measure something that seems beyond all measure, space itself. And to do that, we turn to light. Light is not only illumination, it is a ruler, a clock, a messenger. Every photon that leaves a star carries a record of distance and time. Traveling at 186,000 miles per second, it moves faster than anything else known. When light travels for 1 second, we say it has gone 1 light second. When it travels for a year, we call that a light year, about 6 trillion miles of space, crossed by a single tireless wave of energy. It is the unit by which the universe measures itself, the cosmic heartbeat that turns emptiness into a map. To describe even our immediate neighborhood in the cosmos, we must multiply this scale many times. The distance from the Earth to the Sun, about 93 million miles, is only 8 light minutes. The light that warms your face on a calm morning left the Sun when you were still finishing your first cup of tea. Beyond that, the nearest star, Proxima Centauri, lies more than 4 light years away. The light we see from it tonight began its journey when the calendar read 4 years earlier. If we were to travel there at the speed of our fastest spacecraft, it would take tens of thousands of years. That is the beginning of what we mean when we speak of the Milky Way's scale. Our galaxy is not small. It is an enormous disk of stars, roughly 100,000 light-years wide. If you were to cross it at the speed of light, you would still need 100,000 years to reach the other side. In miles, that is roughly 600 trillion times the circumference of the Earth, a span so immense that human comparison nearly collapses under it. The numbers become abstract, so we turn again to imagination. Imagine walking along a beach. A single grain of sand beneath your foot could represent our Sunday. If every grain of sand on that beach were another star, you would only begin to fill one small corner of the Milky Way. Astronomers once tried to count the stars not in the entire sky, but in one tiny patch of it. They pointed telescopes toward what seemed an empty region, a space of darkness between familiar constellations, and let them collect light for days. What appeared on those images was not emptiness at all, but thousands of faint galaxies, each containing billions of stars. The lesson is simple, but profound. The more precisely we measure the sky, the less empty it becomes. The earliest human attempts to measure the heavens were not unlike this efforts to bring order to something immeasurable. Ancient astronomers tracked the movement of stars and planets using simple geometry, marking the sky with patience and faith. Later, the invention of the telescope turned the infinite into something we could record. We learned that the stars are not scattered randomly, but arranged in patterns and depths, and that our Sun is one among hundreds of billions orbiting a common center. Today we map the galaxy using more than light itself. We use parallax, the apparent shift in a star's position as the Earth moves around the Sunday. By measuring that tiny change, often just a fraction of a second, of arc astronomers can calculate distances across hundreds or thousands of light years. Satellites like Gaia, launched by the European Space Agency, have measured the positions and motions of over 1 billion stars, creating the most precise three-dimensional map of our galaxy ever made. With every observation, the Milky Way becomes a little less mysterious, and yet somehow even more wondrous. Still, the scale remains beyond intuition. Let's imagine shrinking the entire Milky Way until it fits within a single city. In this scale, our Sun would be smaller than a grain of dust, and the nearest star would lie several blocks away. The entire solar system from Mercury to the outermost edge of the Oort cloud would fit comfortably inside a small park. Beyond it, the galaxy's spiral arms would stretch across miles of invisible distance, luminous pathways curving softly in the dark. But the galaxy is not a static structure. It spins. Stars orbit the center like planets around the Sun, though on much grander timescales. Our solar system travels at about 500,000 miles per hour, completing one galactic orbit every 230 million years. Since its birth, the Sun has circled the Milky Way more than 20 times. During its last lap, dinosaurs roamed the Earth, and the continents were joined as one. Time on this scale becomes a form of motion, slow, steady, vast, beyond measure. Astronomers define the Milky Way's shape as a barred spiral, a disk of stars with sweeping arms, and a dense, central bulge. Yet even this structure is hard to describe without numbers that stagger the mind. The disk alone is about 1,000 light-years thick. The central bulge, where stars are older and more tightly packed, glows with a warm golden light, while the outer arms shimmer blue with younger stars. Beyond the disk lies a halo of dark matter, an invisible sphere that extends far beyond the visible edges, shaping the motion of every star within. When we speak of measuring the galaxy, we are really measuring our own limits of perception. We cannot see the Milky Way in its entirety from within it, just as we cannot see the shape of the ocean while swimming in its waves. We observe from one small corner, collecting light and data and assembling them into a picture. What emerges is both familiar and humbling, a home that is too vast to ever be fully seen, but close enough to feel. Our tools of measurement, telescopes, spectrometers, radio arrays, are extensions of our senses. They allow us to perceive wavelengths of light far beyond human vision. In radio light, the Milky Way glows with the emission of neutral hydrogen gas. In infrared, dust clouds appear transparent, revealing the stars hidden behind them. In X-rays, the galaxy reveals its high-energy heart remnants of supernovae neutron stars and the faint whispers of the central black hole. Each form of light adds a new layer of understanding, and together they form a multi-dimensional portrait of the galaxy's body. And yet, despite all these instruments and numbers, there is something immeasurable that lingers. The distances between stars are too vast, the timescales too long for us ever to witness most of what we describe. Light itself is a compromise, a messenger that tells us how things once were, never how they are now. The stars we see tonight may already have changed or vanished, their light still traveling toward us through space and time. In this way, every night sky is a memory, a visible echo of what was. Still, we keep measuring. We build larger telescopes, launch spacecraft to the edges of the solar system, and send probes beyond. Voyager 1, launched in 1977, has now traveled more than 14 billion miles from Earth. Yet it has not even left the faintest shadow of the Milky Way's scale. It drifts now through interstellar space, still sending back faint signals, a tiny ripple in the ocean of stars. And perhaps that is the beauty of it. The attempt to measure the immeasurable is itself an act of wonder. To stretch our minds to scales we cannot inhabit is to recognize both our smallness and our capacity for understanding. We may never walk across the galaxy but through light, and thought we can know it not in distance, but in comprehension. When we speak of the Milky Way's size, we are not only measuring distance, we are measuring time, history, and motion. The galaxy is both map and memory, a record of every star that has ever lived within it. Its arms contain the story of creation and dissolution, of fusion and dust, of endless cycles that began long before Earth and will continue long after it. So as you breathe slowly and imagine that glowing band across the night, know that what you see is only the nearest layer of something vast, a structure so immense that it bends both time and thought. You are looking not into distance, but into duration, into the quiet unfolding of light over cosmic ages. And in that calm expanse, we take the first step of our journey from the scale of the human to the scale of the galactic, from the light of our own sun to the boundless heart of the Milky Way. Beyond the numbers, beyond the light years, something greater waits, the place we call home among the stars. The Milky Way, our home, is not a single body suspended in space, but a great rotating collection of stars, gas dust, and invisible matter, a living structure bound together by gravity. It stretches more than 100,000 light-years, from edge to edge, containing between 200 and 400 billion stars, and possibly just as many planets. When we gaze up at the night sky and see that pale, misty band cutting across the darkness, we are looking along the inner curve of this immense spiral, seeing our galaxy from within. To imagine the Milky Way properly, we must first step outside it, in thought, if not in body. Picture a spiral seen from above, a glowing disk, gently curved its arms, winding outward from a dense, luminous center. The arms are not solid. They are regions of higher density, where stars and gas clouds gather like waves frozen in motion. The light we see is the combined radiance of countless suns, each separated by trillions of miles, their combined glow softened by distance into a single luminous haze. At the center of the Milky Way lies the galactic bulge, a thick spherical region filled with older stars and ancient clusters. Its light glows with a subtle golden hue, the color of age and heat. Here, stars orbit close together, moving at tremendous speeds around the galaxy's hidden anchor, the supermassive black hole known as Sagittarius A*. Though this black hole is invisible to the eye, its gravity shapes everything around it. The stars closest to it trace tight, elegant ellipses, completing their orbits in just a few decades. Their motion reveals the presence of a mass millions of times heavier than our Sun, compressed into a space smaller than the orbit of Mercury. Surrounding this central bulge, the Milky Way's disk extends outward like a great celestial whirlpool. It is here within the disk that the spiral arms wind long sweeping lanes of stars, dust and nebulae that circle the galaxy's heart. The disk itself is relatively thin, about 1,000 light-years thick, yet it stretches for more than 100,000 light-years across. Within it lies nearly all the visible matter of the galaxy, the stars that define our constellations, the gas that forms new suns, and the dust that scatters light into soft shades of blue and red. The spiral arms are named for the constellations they pass, through the Perseus arm, the Sagittarius arm, the Scutum, Centaurus arm, and smaller branches like the Orion spur, where our Sun resides. Each arm moves through the galaxy like a slow wave, a region of compression that gathers gas and triggers the birth of stars. Young hot blue stars cluster along these arms, their light outlining the Milky Way's elegant shape. Older, cooler stars drift in the spaces between, forming a diffuse background that gives the disk its silvery glow. Between the stars, a fine mist of gas and dust weaves through the galaxy. This interstellar medium is thin, beyond imagining a handful of atoms per cubic inch, yet it is the material from which stars are born. Clouds of hydrogen gather under the pull of gravity, collapse, and ignite. In the spiral arms, where gravity and density align, these clouds form luminous regions of starbirth, known as nebulae. The Orion Nebula, visible even from Earth's surface, is one such region, a stellar nursery, glowing with the light of its newborn suns. Seen from a distance, the Milky Way's structure would appear both graceful and complex. Its spiral pattern is not rigid. The arms shift and ripple over time like tides responding to invisible forces. The disk itself is slightly warped, bending upward on one side and downward on the other, perhaps shaped by the gravitational pull of nearby galaxies. The entire structure rotates slowly, completing one turn every 230 million years. Yet within that grand motion, each star follows its own path. Some faster, some slower, all guided by the same gravitational rhythm. Beyond the luminous disk lies the galactic halo, a vast spherical region that extends far beyond the visible stars. Here, scattered clusters and ancient stars orbit in eccentric tilted paths. The halo also contains an unseen mass, dark matter, that outweighs all the visible material combined. This invisible halo stretches hundreds of thousands of light years in every direction, shaping the orbits of the stars and keeping the galaxy's structure stable. Without it, the Milky Way's rotation would fling its stars outward into space. Dark matter does not emit or absorb light. We cannot see it directly, yet its gravitational pull reveals its presence. When astronomers measured the speeds of stars far from the galactic center, they found something unexpected. Those outer stars move just as fast as those near the center. According to Newton's laws, the rotation should slow with distance, but it does not. The only explanation is that a vast amount of unseen mass surrounds the galaxy, holding it together. This dark halo is the Milky Way's invisible foundation, the silent skeleton that gives it form. The thickness of the Milky Way is not only physical, but temporal. In its stars lies a record of cosmic history. The oldest stars found in the halo and bulge date back more than 12 billion years, nearly to the beginning of the universe. They are poor in heavy elements, formed before many supernovae had enriched the cosmos with new materials. Younger stars like the Sun contain more complex elements, carbon, oxygen, iron, forged in the hearts of earlier generations. Each star in its composition carries the memory of those that came before. Astronomers read these stellar fingerprints like historians. By studying the light from stars, their spectra, we can tell their age, temperature, and chemical makeup. We can trace how matter cycles through the galaxy, from gas clouds to stars, from stars to supernovae and back again. The Milky Way is not just a structure in space. It is a system of evolution, a dynamic balance between creation and decay. Even the spaces between stars are alive with movement. Streams of gas flow along the spiral arms, guided by gravity and magnetic fields. Shockwaves from supernovae ripple outward, compressing clouds and triggering new bursts of formation. Clusters drift apart, scattering their stars into the general population. It is a constant circulation, a galactic heartbeat beating over eons. The Milky Way does not exist in isolation. Surrounding it are smaller galaxies, like the Magellanic Clouds, which orbit as companions. These dwarf galaxies are drawn slowly inward, their gas pulled into long filaments that feed the Milky Way's growth. Over billions of years, they will merge with our galaxy, adding their stars and material to the great spiral. The process is slow, almost imperceptible, yet inevitable. The quiet nourishment of a living system. When we study the Milky Way, we are really studying ourselves, our cosmic neighborhood, our origins, our home. Every point of light in the night sky belongs to this one galaxy. Even the dark spaces between those lights are part of its body. The Sun, one among hundreds of billions, lies about 26,000 light-years from the center on the inner edge of the Orion Spur. It moves with the rest of the disk, orbiting the center of the galaxy at a speed of 500,000 miles per hour. Yet in that vast motion, it carries us the Earth, the Moon, and all the fragile life that has ever existed here. And so when you step outside and look up, what you see is not distant at all. You are looking into your own galaxy through the dust and light of home. The band of the Milky Way arcing across the sky is the plane of our disk, seen from within a cross-section of billions of stars, layered together, their light softened by dust. Each speck of light, each faint shimmer, is part of the same system that holds us. It is easy to forget that the Milky Way is moving, not only spinning, but drifting through space, with the rest of the local group carried toward the constellation Virgo at hundreds of thousands of miles per hour. The galaxy itself is in orbit, part of a larger structure that extends beyond imagination. We will come to that later, but for now, it is enough to know that even our home is not still. It breathes, it turns, and it changes like everything else in the universe. In every sense, the Milky Way is alive, not in the way a living organism breathes or thinks, but in its constant motion and renewal. It forms, it consumes, it grows. Its stars are born and die. Its structure bends and flows. It is a great organism made of light and gravity, with its own rhythm, its own pulse. As you breathe, slowly imagine drifting outward through this vast spiral, past the sun, past the clusters of stars, past the luminous arms, curling gently around the center. See the golden bulge glowing beneath a haze of dust, the spiral arms stretching into darkness, the halo shimmering faintly with unseen mass. Feel the slow rotation, the turning of billions of suns around a single gravitational heart. This is our home, vast, ancient, and alive. And though it is only one of billions of galaxies scattered through the cosmos, it is the one that carries us, the one we know, by light and by love. To understand it is to understand not just where we are, but who we are. Matter, made from its stars. Thought formed from its dust, life born in the quiet curve of one of its arms. And as we move deeper into its structure, we will discover something more, the invisible framework that holds it all together. A hidden architecture that binds light and gravity in perfect balance. For beyond the glow of stars lies the unseen, the mysterious substance that keeps the galaxy whole. In the great stillness of the night sky, we see light stars, nebulae, galaxies scattered like islands on an infinite sea. But what we see is only a fraction of what exists. The true structure of the Milky Way, and indeed of the universe, is shaped not only by what glows, but by what does not. The luminous matter star's gas dust makes up less than 15% of the galaxy's total mass. The rest is unseen, silent, and invisible to every wavelength of light. It neither shines nor absorbs, yet it bends the paths of stars and the fabric of space itself. This invisible foundation is what astronomers call dark matter, the hidden architecture of the cosmos. When we first learned to measure the Milky Way's motion, something didn't add up. According to Newtonian, gravity, stars farther from the galactic center should move more slowly than those closer, in just as the outer planets move more slowly around the Sunday. But observations told a different story. The rotation curves of the galaxy graphs, plotting orbital speed against distance, refused to drop. Stars in the outermost regions moved just as fast as those near the core. The Milky Way, it seemed, was spinning faster than its visible mass could explain. Something unseen was holding it together. This discrepancy was first noticed in other galaxies by astronomer Vera Rubin. In the 1970 seconds, she studied spiral galaxies and found the same pattern everywhere. The stars at the edges were moving too quickly to be bound by visible matter alone. Without some additional mass providing gravitational support, those galaxies would fly apart. The conclusion was inescapable. The universe must contain a vast amount of invisible material, outweighing the luminous matter by a factor of 5 or more. Dark matter does not emit, reflect, or absorb light. It cannot be seen directly through telescopes or detected by any traditional means. Its existence is known only through its effects, the way it shapes motion, bends light, and holds galaxies together. The Milky Way's dark matter halo extends far beyond its visible disk, a vast spherical envelope that reaches hundreds of thousands of light years in every direction. It is this halo that allows the outer stars to orbit at the speeds they do. To picture it, imagine the Milky Way's glowing spiral as a luminous shell floating inside an invisible sphere. The stars and gas form the bright surface, but most of the mass, most of the gravity, lies in the unseen volume beyond. It is as if the galaxy were a lantern surrounded by a globe of transparent glass. The shape of the whole determined not by light, but by the shadow that light cannot touch. The nature of dark matter remains one of the most profound mysteries in science. It is not made of atoms or any known form of ordinary matter. It does not interact with light or magnetism, and it passes through normal matter almost without resistance. It could be composed of WIMPs weakly interacting massive particles' actions, or some other exotic form of matter not yet discovered. Particle physicists build detectors deep underground, shielded from cosmic rays, to search for faint collisions between dark matter particles and atomic nuclei. So far, no definitive detection has been made, though the evidence from astronomy is overwhelming. The Milky Way is not the only galaxy wrapped in this invisible substance. Every galaxy we have ever studied appears to be embedded in a dark halo. Clusters of galaxies too are held together by it. Even on the scale of the universe itself, dark matter acts as scaffolding, a cosmic framework upon which galaxies form. Without it, the early universe's slight irregularities in density would never have grown large enough to create stars and galaxies. Dark matter is the quiet architect of everything that shines. We can even see its influence indirectly through a phenomenon called gravitational lensing. When light from a distant galaxy passes near a massive cluster of galaxies, the gravity of the dark matter in that cluster bends the light, distorting and magnifying the image. These cosmic lenses allow astronomers to map the distribution of invisible mass by measuring how light curves around it. What they find confirms what theory predicts: dark matter forms vast filaments and halos, interconnecting galaxies like threads in a grand cosmic web. Within the Milky Way, dark matter moves differently from stars and gas. While luminous matter settles into the thin disk, dark matter remains in a roughly spherical halo. It does not collide, heat up, or cool down as ordinary gas does. It simply flows under the influence of gravity, forming a smooth background potential that guides the motion of everything else. The stars orbit within this gravitational field, like insects caught in a silent current. Even though dark matter dominates the galaxy's mass, it is ghostly and diffuse. If you could somehow hold a handful of it, it would pass through your fingers unnoticed. Yet every second, trillions of dark matter particles are thought to be streaming through your body, through the Earth, and through every atom around you. Invisible, intangible, unstoppable. Understanding dark matter is not only a question of astronomy, but of physics. The search for it connects the smallest and the largest scales in nature, from subatomic particles to galactic halos. The Large Hadron Collider has probed high-energy collisions hoping to produce dark matter particles, while observatories like Planck and James Webb trace its effects across the cosmic background. Together they form a dialogue between the very small and the very vast. Dark matter's presence also helps explain the Milky Way's past and future. Simulations show that galaxies formed within regions of high dark matter density in the early universe. These halos gathered gas and dust, which cooled and condensed into stars. Over billions of years, small halos merged into larger ones, building up the great galaxies we see today. The Milky Way's dark matter halo, then, is ancient, a relic of the universe's earliest moments, predating even the first stars. The shape of this halo also determines the galaxy's future interactions. The gravitational pull between dark matter halos is what draws galaxies toward each other, setting the stage for collisions and mergers, like the eventual meeting of the Milky Way and Andromeda. Dark matter is, in a sense, the unseen hand, guiding cosmic destiny. Despite its mystery, dark matter has a quiet elegance. It is the foundation, without which nothing would stand. It does not seek attention, it does not glow, yet its influence is everywhere. The stars that sparkle, the galaxies that spin, the structures that rise across billions of light years, all of them owe their existence to something we cannot see. When we look at the night sky, we tend to think that we are seeing reality as it is, but we are not. We are seeing the faint surface of a much larger truth. The real shape of the galaxy is invisible to our eyes, perceptible only through mathematics and motion. To know the Milky Way fully is to see both the light that shines and the darkness that holds it. Perhaps that is the quiet lesson hidden in dark matter, that what sustains the visible is often invisible, and that what we cannot see may be the most essential of all. The same principle echoes through everything we know, the unseen forces of gravity, magnetism, thought, and love. The universe, it seems, is built not only of matter, but of mystery. So as we drift through the Milky Way's unseen halo, we are surrounded by ghosts, not of the dead, but of the unseen. The galaxy's stars move in harmony because of them. The sun, the earth, you, and everything you have ever known are carried safely through space within that dark embrace. And yet even this invisible mass is only part of a greater pattern. Beyond the dark matter halo lies another rhythm, one even more dynamic, and visible, the ceaseless cycle of starbirth and destruction that fills the galaxy with light. For as darkness holds the structure together, light renews it. The two are partners in the endless dance of creation. The Milky Way is a vast and patient workshop of transformation. Every atom that drifts through its spiral arms, every speck of dust that floats between the stars, is part of a continuous cycle, the making and unmaking of light. Within the cold darkness of space, clouds of gas collapse, ignite, and shine. Then, when their fuel is spent, they dissolve again into the material that will one day form new suns, new worlds, and perhaps new life. To understand the galaxy is to understand this rhythm, the quiet exchange between death and creation, between the stillness of space and the fire of stars. It begins in darkness. Between the stars there are immense clouds of cold hydrogen gas, stretching for hundreds of light years. These are the molecular clouds, the nurseries of stars. Though invisible to the naked eye, they are the densest regions of the interstellar medium, a place where matter gathers and waits. Inside them, pockets of gas become unstable under their own gravity. The material begins to fall inward, compressing and heating, until at last Deep within the cloud, a point of fusion ignites. A star is born. The moment a star forms, it begins to reshape its surroundings. The radiation from its surface pushes back against the gas, carving out bright cavities and glowing regions called H2 regions. In images captured by telescopes, these areas glow in shades of pink and red, illuminated by the ultraviolet light of newborn stars. The most famous examples, the Orion Nebula, the Eagle Nebula, the Carina Nebula, are great pillars of dust and light, shaped by stellar winds and radiation. To look at them is to see creation frozen in motion, a glimpse of the galaxy's constant renewal. Stars forming groups known as clusters from the same cloud of gas. They begin their lives close together, but as time passes, gravitational interactions scatter them across the galaxy. Some drift into the spiral arms, others fall toward the galactic center. A few ejected by gravitational slingshots may even leave the Milky Way entirely destined to wander intergalactic space. But wherever they go, each star carries the memory of its birthplace. In its composition, the ratio of elements forged in earlier generations. The life of a star depends on its mass. The smallest stars, red dwarfs, burn dimly and steadily, consuming their fuel so slowly that they can live for trillions of years. None of them have yet reached the end of their lives, since the universe itself is not old enough. Medium stars like our Sun shine for billions of years before exhausting the hydrogen in their cores. When that happens, the balance between gravity and pressure breaks, and the star expands into a red giant. Its outer layers drift away, forming a glowing shell of gas called a planetary nebula, while the core collapses into a dense white-hot remnant, a white dwarf. These white dwarfs no longer fuse new elements. They simply cool over time, fading slowly into the dark. Yet their passing is not an end. The gas they release enriches the interstellar medium with heavier elements, carbon, oxygen, and nitrogen, the essential ingredients of planets and life. Every breath you take, every cell in your body contains atoms once cast off by dying stars. The more massive stars live faster and die far more violently. When they reach the end of their fuel supply, they cannot resist the inward pull of gravity. Their cores collapse in a fraction of a second, triggering an immense explosion, a supernova. For a brief time, a single star can outshine an entire galaxy. The blast sends shockwaves across space, compressing nearby gas and igniting the birth of new stars. From destruction comes creation. The cycle begins again. In the heart of such an explosion, the temperatures and pressures are so extreme that new elements are forged: iron, gold, uranium, the building blocks of worlds and life. What we wear as gold on our fingers, what flows as iron through our veins, once formed in the death throes of massive stars. We are, as the physicist Carl Sagan once said, star stuff. But that phrase, poetic as it is also literal. The Milky Way's arms are filled with the ashes of stars, reborn as future suns and planets. When a massive star dies, what remains depends on its size. Some leave behind neutron stars, incredibly dense spheres, no wider than a city yet containing more mass than the Sunday. Others collapse entirely, forming black holes, where gravity is so strong that not even light can escape. These remnants are the hidden punctuation marks in the story of the galaxy, invisible but powerful, shaping their surroundings through gravity and radiation. The space between the stars is not empty. It is filled with the whispering aftermath of these lives and death's shock waves, gas streams, and radiation fields that crisscross the disk. The interstellar medium, enriched by each generation of stars, carries traces of complex molecules: water, carbon monoxide, formaldehyde, and even amino acids. Within dense clouds, these molecules stick to dust grains, forming icy coatings that drift for millions of years. when a new star forms, its heat evaporates these ices, releasing the molecules into space. In this way, the chemistry of life becomes scattered across the galaxy. The Sun itself was born about 4-6 billion years ago in one such stellar nursery. Evidence from meteorites suggests that a nearby supernova exploded around the time of its birth, enriching the solar nebula with heavy elements. The planets, including Earth, condensed from this dust and gas, their cores made from metals forged in ancient stars. Every mountain, every ocean, every living thing is part of that inheritance. The latest chapter in the Milky Way's long cycle of renewal. In the Milky Way star, formation is not constant but rhythmic. The spiral arms act like waves of density compressing gas as they move through the disk. Where the gas is densest, new stars ignite. Where it is thin, the light fades. This pattern gives the galaxy its shimmering spiral design, a living rhythm written in gravity and time. The rate of star formation today is modest, about 1 or 2 new stars per year. Yet each of those stars will shine for billions of years, contributing to the quiet endurance of the whole. The galaxy's beauty lies in this balance, the harmony between chaos and order. Every explosion leads to creation. Every collapse leads to motion. The elements born in supernovae flow into new systems, forming planets that may one day gaze back at the stars and wonder. Across billions of years, this recycling of matter has filled the Milky Way with the materials of thought and consciousness. In a sense, the galaxy is learning about itself through us, through the instruments we build, through the curiosity that drives us to look up. Science tells us that nothing is lost, only transformed. The energy that burns in stars, the matter that forms planets, and even the thoughts that pass through our minds, all come from the same source, the great reservoir of the universe. The atoms in your body were once part of clouds, stars, and supernovae. They will return to space one day, to be reused in forms yet unknown. It is a cycle without beginning or end, a kind of cosmic breathing that sustains the Milky Way's existence. The galaxy viewed this way is not a static collection of stars, but a living network, an organism of light and shadow, continually renewing itself. Its life cycle is both delicate and enduring, its rhythm, both ancient and ongoing. We measure it not in centuries or millennia, but in epochs and ages intervals so vast that even destruction becomes a kind of peace. As you imagine drifting through the Milky Way's glowing arms, think of this rhythm: clouds forming stars, stars releasing light, light scattering dust, dust forming clouds again. It is a pattern as old as time, and it continues even now, quietly, invisibly, all around us. Every point of starlight above you tonight is part of this grand circulation, part of a story that began long before the Earth and will continue long after it. And as this endless rhythm continues, something deeper begins to emerge. A sense of movement, not just among stars, but within the galaxy itself. The Milky Way, with all its cycles and transformations, is not fixed in space. It turns gracefully, slowly, perpetually, every star, a note in an unending symphony. For beyond the birth and death of stars lies another kind of harmony, the great sweeping motion of the galaxy as a whole. A motion so vast, so gentle, that to understand it is to glimpse the quiet pulse of the universe itself. The Milky Way is a vast and patient workshop of transformation. Every atom that drifts through its spiral arms, every speck of dust that floats between the stars, is part of a continuous cycle, the making and unmaking of light. Within the cold darkness of space, Clouds of gas collapse, ignite, and shine. Then when their fuel is spent, they dissolve again into the material that will one day form new suns, new worlds, and perhaps new life. To understand the galaxy is to understand this rhythm, the quiet exchange between death and creation, between the stillness of space and the fire of stars. It begins in darkness. Between the stars, there are immense clouds of cold hydrogen gas stretching for hundreds of light years. These are the molecular clouds, the nurseries of stars. Though invisible to the naked eye, they are the densest regions of the interstellar medium, a place where matter gathers and waits. Inside them, pockets of gas become unstable under their own gravity. The material begins to fall inward, compressing and heating, until at last, deep within the cloud, a point of fusion ignites. A star is born. The moment a star forms, it begins to reshape its surroundings. The radiation from its surface pushes back against the gas, carving out bright cavities and glowing regions called H2 regions. In images captured by telescopes, these areas glow in shades of pink and red, illuminated by the ultraviolet light of newborn stars. The most famous examples, the Orion Nebula, the Eagle Nebula, the Carina Nebula, are great pillars of dust and light, shaped by stellar winds and radiation. To look at them is to see creation frozen in motion, a glimpse of the galaxy's constant renewal. Stars form in groups known as clusters from the same cloud of gas. They begin their lives close together, but as time passes, gravitational interactions scatter them across the galaxy. Some drift into the spiral arms. Others fall toward the galactic center. A few, ejected by gravitational slingshots, may even leave the Milky Way, entirely destined to wander intergalactic space. But wherever they go, each star carries the memory of its birthplace in its composition, the ratio of elements forged in earlier generations. The life of a star depends on its mass. The smallest stars, red dwarfs, burn dimly and steadily, consuming their fuel so slowly that they can live for trillions of years. None of them have yet reached the end of their lives, since the universe itself is not old enough. Medium stars, like our Sun, shine for billions of years before exhausting the hydrogen in their cores. When that happens, the balance between gravity and pressure breaks, and the star expands into a red giant. Its outer layers drift away, forming a glowing shell of gas called a planetary nebula, while the core collapses into a dense white-hot remnant, a white dwarf. These white dwarfs no longer fuse new elements. They simply cool over time, fading slowly into the dark. Yet their passing is not an end. The gas they release enriches the interstellar medium with heavier elements, carbon, oxygen, and nitrogen, the essential ingredients of planets and life. Every breath you take, every cell in your body contains atoms once cast off by dying stars. The more massive stars live faster and die far more violently. When they reach the end of their fuel supply, they cannot resist the inward pull of gravity. Their cores collapse in a fraction of a second, triggering an immense explosion, a supernova. For a brief time, a single star can outshine an entire galaxy. The blast sends shockwaves across space, compressing nearby gas and igniting the birth of new stars. From destruction comes creation. The cycle begins again. In the heart of such an explosion, the temperatures and pressures are so extreme that new elements are forged: iron, gold, uranium, the building blocks of worlds and life. What we wear as gold on our fingers, what flows as iron through our veins, once formed in the death throes of massive stars. We are, as the physicist Carl Sagan once said, star stuff. But that phrase, poetic as it is also literal. The Milky Way's arms are filled with the ashes of stars reborn as future suns and planets. When a massive star dies, what remains depends on its size. Some leave behind neutron stars, incredibly dense spheres, no wider than a city yet containing more mass than the Sunday others, collapse entirely, forming black holes, where gravity is so strong that not even light can escape. These remnants are the hidden punctuation marks in the story of the galaxy, invisible but powerful, shaping their surroundings through gravity and radiation. The space between the stars is not empty. It is filled with the whispering aftermath of these lives and deaths, shockwaves, gas streams, and radiation fields that crisscross the disk. The interstellar medium, enriched by each generation of stars, carries traces of complex molecules, water, carbon monoxide, formaldehyde, and even amino acids. Within dense clouds, these molecules stick to dust grains, forming icy coatings that drift for millions of years. When a new star forms, its heat evaporates these ices, releasing the molecules into space. In this way, the chemistry of life becomes scattered across the galaxy. The Sun itself was born about 4.6 billion years ago in one such stellar nursery. Evidence from meteorites suggests that a nearby supernova exploded around the time of its birth, enriching the solar nebula with heavy elements. The planets, including Earth, condensed from this dust and gas, their cores made from metals forged in ancient stars. Every mountain, every ocean, every living thing is part of that inheritance. The latest chapter in the Milky Way's long cycle of renewal. In the Milky Way, star formation is not constant, but rhythmic. The spiral arms act like waves of density, compressing gas as they move through the disk. Where the gas is densest, new stars ignite. Where it is thin, the light fades. This pattern gives the galaxy its shimmering spiral design, a living rhythm written in gravity and time. The rate of star formation today is modest, about 1 or 2 new stars per year. Yet each of those stars will shine for billions of years, contributing to the quiet endurance of the whole. The galaxy's beauty lies in this balance, the harmony between chaos and order. Every explosion leads to creation. Every collapse leads to motion. The elements born in supernovae flow into new systems, forming planets that may one day gaze back at the stars and wonder. Across billions of years, this recycling of matter has filled the Milky Way with the materials of thought and consciousness. In a sense, the galaxy is learning about itself through us, through the instruments we build, through the curiosity that drives us to look up. Science tells us that nothing is lost, only transformed. The energy that burns in stars, the matter that forms planets, and even the thoughts that pass through our minds, all come from the same source, the great reservoir of the universe. The atoms in your body were once part of clouds, stars, and supernovae. They will return to space one day, to be reused in forms yet unknown. It is a cycle without beginning or end, a kind of cosmic breathing that sustains the Milky Way's existence. The galaxy, viewed this way, is not a static collection of stars, but a living network, an organism of light and shadow continually renewing itself. Its life cycle is both delicate and enduring, its rhythm, both ancient and ongoing. We measure it not in centuries or millennia, but in epochs and ages intervals, so vast that even destruction becomes a kind of peace. As you imagine drifting through the Milky Way's glowing arms, think of this rhythm: clouds forming stars, stars releasing light, light scattering dust, dust forming clouds again. It is a pattern as old as time, and it continues even now, quietly, invisibly, all around us. Every point of starlight above you tonight is part of this grand circulation, part of a story that began long before the Earth and will continue long after it. And as this endless rhythm continues, something deeper begins to emerge, a sense of movement, not just among stars, but within the galaxy itself. The Milky Way, with all its cycles and transformations, is not fixed in space. It turns gracefully, slowly, perpetually, every star a note in an unending symphony. For beyond the birth and death of stars lies another kind of harmony, the great sweeping motion of the galaxy as a whole, a motion so vast, so gentle, that to understand it is to glimpse the quiet pulse of the universe itself. The Milky Way is never still. Though we imagine the heavens as a fixed dome of stars, every point of light in the night sky is in motion, drifting, orbiting, circling the galaxy's center in a rhythm older than time itself. The galaxy is a vast gravitational symphony, each star a note, each orbit a phrase, all woven together into a cosmic melody that plays across billions of years. To perceive it is to understand that what seems quiet is actually filled with graceful, ceaseless motion. Our solar system, along with the Sun and its family of planets, moves through this galactic music at nearly 500,000 miles per hour. It follows an orbit around the Milky Way's center, completing a full revolution. Roughly every 230 million years, a single galactic year. That means, since the Sun's birth, it has circled the galaxy about 20 times. When the dinosaurs walked the Earth, we were on nearly the opposite side of the Milky Way from where we are now. The galaxy turns slowly, almost imperceptibly, yet its scale makes even slow motion profound. This rotation is not rigid. The Milky Way's stars do not move like points on a spinning wheel, but rather like dancers in a vast, spiraling pattern. Each star's orbit depends on its distance from the center and on the gravitational pull of the mass within that radius. The inner stars close to the dense bulge move faster. Those farther out move slower, though not as slow as Newton's equations would predict, thanks to the binding influence of dark matter. The result is a delicate balance, a choreography of billions of stars that maintain the galaxy's spiral form while never colliding, never tangling, all moving together through the void. If you could watch the Milky Way from above, sped up to human time, you would see the entire disk, breathing arms curling and uncurling like waves in a great sea. Each orbiting star, gas, cloud and cluster plays a part in this slow rhythm. The spiral arms are not fixed lines of stars, but waves of density regions where matter gathers briefly before flowing onward. As the wave passes, stars are born, shine and drift away. The pattern itself endures, though its components constantly change. In this way, the galaxy behaves much like sound structure sustained by motion. The stars and gas respond to gravity, as strings respond to vibration. The pitch of the music is set by the mass of the galaxy, its rhythm by the rotation of its disk. Though the melody of the Milky Way is far beyond the range of human hearing, its harmony can be seen in light. Radio telescopes trace the hydrogen gas that fills the arms, mapping their graceful sweep. Infrared observatories peer through the dust, revealing clusters and lanes of stars that follow the galaxy's spiral flow. The Milky Way's motion is not limited to rotation alone. The entire disk wobbles, bending upward on one side and downward on the other, like a vast plate flexing under unseen tension. Astronomers believe this warp may be caused by gravitational interactions with nearby dwarf galaxies, the Magellanic Clouds, or by uneven flows of dark matter in the halo. This bending motion ripples slowly through the disk, a galactic heartbeat with a rhythm measured not in seconds, but in millions of years. Even the Sun's path is not a perfect circle. It oscillates gently above and below the galactic plane, bobbing through the midplane every 30 million years or so. As it rises and falls, it passes through regions of greater and lesser density, spiral arms, dust lanes, magnetic fields, each influencing the solar system in subtle ways. Some scientists speculate that these passages may have affected the history of life on Earth, as cosmic rays and gravitational tides subtly shape the environment in which our planet orbits. The stars of the Milky Way move together, yet not uniformly. The galaxy is filled with streams, ancient rivers of stars left behind by smaller galaxies, long absorbed. The most famous, the Sagittarius stream, wraps around the Milky Way like a faint ribbon, the remnant of a dwarf galaxy, torn apart by tidal forces. These streams are the galaxy's fossil traces of its evolutionary past. They reveal that the Milky Way's history is one of continual merging and transformation, a dance of accretion and renewal that continues even now. This slow dynamism extends to the smallest scales. Star clusters orbit the galaxy as single bodies bound by gravity, yet shaped by the greater gravitational field. Some remain tightly knit like globular clusters, dense spheres of ancient stars that orbit far above the disk relics from the galaxy's youth. Others, like open clusters, gradually dissolve into the background, their stars dispersing into the arms. Even as they vanish, as groups their motions remain coherent for millions of years, faint chords that echo through the galactic music. The interstellar medium moves too. Gas clouds drift along the arms, spiral inward, and interact with shockwaves from supernovae. Magnetic fields thread through them, guiding charged particles in sinuous paths. Every motion adds to the texture of the galactic symphony. The galaxy is not static. Even in its emptiness, it is a dynamic continuum, a field of interacting forces. At the center of this movement lies Sagittarius A times the supermassive black hole that anchors the Milky Way. Its gravity dictates the orbits of stars near the core, but its influence extends far beyond. Around it, a cluster of massive stars moves in tight ellipses, completing orbits in mere decades. These stars trace the invisible curve of space-time. Around the black hole, there dance the most intense movement in the galaxy's symphony. From this heart of gravity, energy flows outward, in X-rays, radio waves, and magnetic storms, influencing the entire central bulge. Beyond the disk, the halo of dark matter participates in its own slow motion. Though invisible, it shapes every orbit, ensuring the coherence of the whole. If the visible stars are the melody, then dark matter provides the underlying bass, deep, unseen, but essential. Without it, the structure of the galaxy would unravel its stars, scattering into the void. Our solar system, for all its speed, moves gently within this grand design. As it orbits the center, it also drifts relative to nearby stars, forming part of the local standard of rest, a shared average motion of the stars in our region of the disk. Against this backdrop, we can measure the sun's own path, a smooth curve through the spiral arm, like a grain of dust caught in a slow whirlpool of light. When we visualize the Milky Way's movement, it is easy to imagine chaos stars colliding, paths crossing. Yet in truth, the distances between stars are so vast that collisions are rare. The galaxy's motion is not violent, but serene, each star moving in predictable arcs, guided by the common gravity of billions of others. The sense of stillness we feel under the night sky comes not from a lack of motion, but from perfect balance, from motion so vast and smooth that it feels like rest. This balance is the defining characteristic of the Milky Way harmony through movement. Every star, every particle of dust, every ripple of gas plays its part. Nothing is out of place, even when chaos seems near. Over time, orbits change, clusters disperse, and streams fade. Yet the overall structure remains a testament to the equilibrium of cosmic forces. To study this motion is to study time itself. The patterns we see now were set in motion billions of years ago, and will continue for billions more. The light from distant stars carries information not only about their position, but about their velocity, how they move where they are going. By measuring these motions, astronomers can reconstruct the Milky Way's past and forecast its future, tracing the arcs of stars as they weave through space. And that future is not one of solitude. Even now, the Milky Way is moving toward its nearest large neighbor, the Andromeda galaxy, drawn together by mutual gravity. The two galaxies approach each other at about 150 miles per second, and in roughly 4 billion years, they will begin to merge. It will be a slow, stately process, lasting billions of years. Not a collision in the way we imagine, but an intermingling, a blending of stars and light. For now, though, our galaxy drifts in graceful motion, its stars circling the unseen heart in endless patterns. To think of it this way is to find peace in motion, to realize that change itself is stability, that even the vastest systems move in quiet cycles. The Milky Way's motion is not a race, but a dance, and every atom within it moves to the same silent rhythm. So as you picture the galaxy turning, vast arms swirling through the night, imagine this music of motion. Imagine every orbit as a note, every rotation as a phrase. From the smallest molecule of gas to the greatest star cluster, all of it plays together, woven into the same celestial composition. And yet, even harmony contains hunger. For beyond this great motion lies another story, one of transformation of galaxies, feeding upon one another in slow, graceful acts of creation. For the Milky Way, this is not the end of motion, but its next expression, the moment when one symphony begins to blend with another. At the center of our galaxy, beneath the shimmering veil of dust and gas, there is a presence both powerful and serene, an immense gravitational heart that holds the Milky Way together. This heart is not a star nor a cluster, but a supermassive black hole, a singularity where matter and energy collapse beyond comprehension. Astronomers call it Sagittarius A times, and though invisible to our eyes, it anchors the galaxy's rhythm, shaping the motion of hundreds of billions of stars. Yet the Milky Way's hunger does not end there. Like all great galaxies, it feeds slowly, gracefully, and eternally. The story of this galactic appetite begins in the quiet pull of gravity. Every star, planet, and cloud of gas within the Milky Way feels the faint attraction of the center, a pull that is strongest near Sagittarius A*. The black hole's mass is estimated at about 4 million times that of the Sun, confined to a region no larger than our solar system. Around it, stars race at astonishing speeds, some completing orbits in little more than a decade. These stars, their paths measured with exquisite precision, reveal the depth of gravity's hold and confirm the presence of an object that no light can escape. And yet, the black hole is not merely a devourer. It is also a regulator, a conductor of energy and order. When gas and dust drift too close, they spiral inward, forming a glowing accretion disk that shines brighter than a million suns. As the material falls, it heats to millions of degrees, emitting X-rays that pierce the surrounding space. Jets of charged particles stream outward at nearly the speed of light, carrying away angular momentum and sculpting the surrounding environment. This process, both violent and precise, allows the galaxy to maintain balance between creation and consumption. The Milky Way's feeding, however, extends far beyond its central black hole. The galaxy itself consumes its smaller neighbors, dwarf galaxies, and star clusters drawn inward by gravity. These interactions are not sudden or chaotic. They unfold over billions of years as streams of stars and gas stretch across the halo, blending slowly into the Milky Way's body. Astronomers have mapped these remnants, ghostly rivers of light known as stellar streams, tracing the paths of past mergers. Each one is a memory of a galaxy long absorbed its stars, now woven into the Milky Way's spiral arms. Among these companions are the Magellanic Clouds, two small irregular galaxies orbiting our own. They are visible from the southern hemisphere as faint smudges in the night sky, trailing behind them long ribbons of gas, the Magellanic Stream drawn out by tidal forces. Over the next few billion years, these galaxies will be consumed, their stars scattered their gas, feeding the Milky Way's next generation of stars. The process is not destruction, but integration, the gentle folding of one system into another. Galaxies grow by merging, and the Milky Way is no exception. Our galaxy's outer halo bears the fingerprints of these ancient encounters. Globular clusters, compact spheres of ancient stars, orbit far beyond the disk. Many of them were likely captured from smaller galaxies, each a fossil of a long-forgotten collision. The halo itself, stretching hundreds of thousands of light-years, is filled with the debris of past meals, faint elongated arcs of stars, remnants of devoured companions that once circled independently. Even within the disk, this hunger leaves its mark. Streams of infalling gas, stripped from smaller galaxies, flow into the spiral arms, replenishing the Milky Way's star-forming regions. Without this steady influx, the galaxy would eventually run out of fuel for new stars. In this way, the act of consumption sustains the cycle of creation. The Milky Way feeds to remain alive, drawing nourishment from the universe around it. This process of cosmic feeding is not unique to our galaxy. It is a universal principle repeated across the cosmos. Galaxies are not isolated islands, but members of a larger community, the cosmic web, where gravity connects everything to everything else. Within that web, galaxies interact, collide, and merge, building ever larger systems. Some grow to contain trillions of stars, while others are stripped bare, reduced to faint streaks of starlight. The Milky Way's hunger, then, is not greed, but participation in the great recycling of the universe. Astronomers studying these interactions use powerful simulations to reconstruct the Milky Way's history. They can see how billions of years ago small protogalaxies collided and merged, their dark matter halos blending into one. These early mergers seeded the central black hole and gave rise to the spiral structure we see today. Each collision left ripples in the motions of stars, in the distribution of gas, in the shape of the halo. Even now, those ripples persist, faint but measurable, like the echoes of an ancient song, still resonating through the galactic body. At the very core of this structure, Sagittarius A times remains mostly quiet, what astronomers call quiescent. It consumes little compared to the active black holes in other galaxies, but there are signs that it has not always been so still. Vast bubbles of high-energy radiation, known as the Fermi bubbles, rise above and below the galactic plane, stretching for tens of thousands of light-years. These colossal structures are thought to be the relics of a powerful outburst from the black hole millions of years ago, when it briefly flared into an active state. Even now, faint gamma rays and X-rays hint that this hunger sometimes awakens. The balance between creation and consumption, between feeding and resting, is what allows galaxies like ours to survive for billions of years. If Sagittarius A times consumed too much, it would flood the galaxy with energy, driving out gas and halting star formation. If it consumed too little, the central regions would grow unstable. Instead, it maintains a delicate equilibrium, its appetite measured by the rhythms of gravity and time. When we study these processes, we find patterns that echo across scales. A star gathers matter from its surroundings until it shines, then sheds that material when its fuel runs out. a galaxy too gathers and releases, balancing accumulation with outflow. Even the universe itself follows this pattern: expansion balanced by gravity, energy balanced by matter. What seems destructive is in truth creative. The Milky Way's hunger also has a future. In about 4 billion years, it will meet its equal, the Andromeda galaxy, in a slow, stately merger. Their dark matter halos are already touching their mutual gravity, drawing them closer. When they collide, the galaxies will pass through one another, their stars rarely colliding, but their shapes transforming. Tidal forces will stretch and twist them, forming long tails of light. Over time, they will settle into a new, larger structure, an elliptical galaxy astronomers call Milkomeda. The black holes at their centers will spiral together and merge, releasing an immense burst of gravitational waves that will ripple across the universe. From the perspective of life on Earth, this future may seem distant, beyond imagining. Yet, in cosmic terms, it is already underway. The hunger that drives galaxies together is the same gravity that keeps the Earth in orbit, that holds your feet to the ground. It is not violence, but inevitability, the slow, patient flow of energy toward balance. When we look at the Milky Way, we see a galaxy that has endured and evolved for more than 13 billion years. Its spiral arms shimmer with the light of countless generations of stars. Its halo holds the remnants of others long gone. Its core, though dark, beats with the rhythm of gravity and time. This is not a static world, but a living system. A cosmic organism, sustained by the balance between giving and taking. And perhaps in a quiet way, it mirrors us. Life itself depends on this same exchange of energy, of matter, of cycles of creation and decay. The galaxy's hunger is our own, the drive to transform, to grow, to become more complex. When we look at the stars, we are not separate from this process. We are its latest expression. So as you drift deeper into thought, imagine this great spiral, its arms turning slowly, its core glowing faintly in invisible light. Picture the faint streams of captured galaxies weaving through its halo, the endless dance of stars around the black hole's quiet heart. This is the Milky Way's hunger, not violent, not cruel, but patient and eternal. And far beyond, another glow begins to rise. A neighboring spiral, faint yet brightening, approaches across the darkness. The two galaxies, drawn together by the same force that holds every star in place, prepare for a meeting billions of years in the making. Beyond hunger lies unity. Beyond motion lies transformation. Across the endless dark of intergalactic space, another spiral galaxy glides silently toward us. It has been moving this way for billions of years, long before Earth formed, long before our sun ignited. Its name is Andromeda, and it is the Milky Way's twin, in both shape and scale. It lies about 2.5 million light-years away, close by cosmic standards, and every second it draws nearer, at about 150 miles per second. The space between us is vast, but gravity is patient. One day, these two great spirals will meet. This coming encounter is not a collision in the way we imagine cars colliding or planets striking. Galaxies are mostly empty space oceans of distance between each star. When the Milky Way and Andromeda finally overlap, their stars will pass between one another almost entirely without contact. No single star will strike another, and yet the entire structure of both galaxies will change. Gravity will stretch and twist them, pulling out long streams of light that arc across the void. Slowly, over billions of years, their separate identities will dissolve into one. To visualize it, imagine two vast whirlpools meeting on a calm sea. At first, their spirals touch, distorting one another's arms. Then, They interweave, creating patterns that shimmer and fold. The water does not shatter, it flows. So too will the Milky Way and Andromeda blend, a slow ballet of motion and mass, light and darkness. When it is done, a single larger galaxy will remain glowing softly where two once turned. Astronomers have modeled this future in exquisite detail. Using computers, they trace the orbits of billions of simulated stars, watching the galaxies approach, merge, and settle. The first encounter will occur in about 4 billion years. The galaxies will pass through one another, their disks stretching into long, luminous tails. The Milky Way's shape will distort its spiral arms, flung outward like ribbons. Andromeda's core will swing past, dragging with it streams of stars that will rain into our galaxy's halo. After this first pass, the galaxies will separate briefly, only to be drawn together again by gravity. In the next few billion years, they will merge completely, their centers coalescing into one. In the aftermath, the delicate spiral structures of both galaxies will fade. The new galaxy, already named by astronomers as Milkomeda, or sometimes Milkdromeda, will take on an elliptical form, smoother and rounder. Its light will be soft and diffuse, the result of countless stars redistributed into new orbits. The night sky, for any observer who might exist then, will be magnificent beyond words. The sky will no longer show a single arc of the Milky Way. Instead, it will blaze with new constellations, fields of light, where once there was dark as Andromeda's stars, join ours in a shared sky. At the heart of this merger, something extraordinary will happen. The supermassive black holes that lie at the centers of both galaxies, Sagittarius A times in the Milky Way, and its Andromedan counterpart, will begin to spiral toward one another. They will dance a slow gravitational waltz, losing energy as they emit gravitational waves, ripples in the fabric of space-time itself. These waves will travel outward at the speed of light, carrying away the memory of the merger. When the two black holes finally meet, they will merge into a single, even more massive black hole, a new heart for a new galaxy. The formation of Milkomeda will not destroy what exists, but transform it. The Sun, by then, an aging star nearing the end of its life, will continue to orbit within this new galactic body, though its path will be altered. Simulations suggest that our solar system will likely survive the merger, perhaps flung to a new orbit farther from the galactic center. From there, any future observers, machines, consciousness, or whatever descendants of humanity might exist, would look up to see a sky filled with 1,000-fold more stars. The meeting of the Milky Way and Andromeda is not unusual. Across the universe, galaxies merge constantly. The largest galaxies in the cosmos, the elliptical giants found at the centers of clusters, are the result of countless such unions. In each case, the process is slow and silent, unfolding over cosmic time. Gravity pulls galaxies together, friction among their gas clouds, sparks, bursts of star formation, and new structures emerge. Destruction and creation happen together, inseparable, eternal. This process is fundamental to cosmic evolution. The universe began as a nearly uniform sea of matter and energy, expanding and cooling. Over billions of years, gravity gathered that matter into the first small galaxies. Those merged into larger ones, which merged again, forming the spirals and ellipticals we see today. Each collision was not an end, but a step toward greater complexity. The Milky Way itself was built from the ashes of many smaller galaxies, and soon it will merge again to continue that story. We might ask, what does it mean for a galaxy to end? In truth, it does not end at all. Its stars continue, its elements persist, its motion endures. The Milky Way will not die in the collision. It will be reborn in a new form, its stars mingled with Andromeda's, its dust recycled into new generations of light. In this sense, the galaxy is like a flame, always changing, never destroyed, passing its energy forward in new patterns of brightness. Astronomers observing distant galaxies can already see versions of this future. Telescopes reveal merging galaxies caught in every stage of interaction, pairs stretching toward one another, their arms connected by luminous bridges, tangled systems where two cores glow within a shared envelope. Smooth ellipticals, their past collisions recorded only in faint ripples of starlight. These are not scenes of chaos, but of transition, nature's way of rebalancing its vast structures. As Andromeda draws closer, subtle effects will begin long before the visible merger. The gravitational attraction between the galaxies will disturb the orbits of stars in their outer halos, pulling them into extended tidal streams. Some of these streams already exist, faintly visible in surveys that map the outermost stars of the Milky Way. They are early notes in the music of merging, soft preludes to a far future event. From Earth over billions of years, the appearance of Andromeda in the night sky will change. Today, it is a faint smudge, visible only in dark, clear skies. But as it approaches, it will grow brighter, more detailed. In 1 billion years, it will span the width of the full moon. In 2 billion, it will fill much of the sky. Its spiral arms will become distinct, its core luminous. Eventually, its light will dominate the heavens, turning the night into a soft cosmic dawn. When the two galaxies finally embrace, the collision will trigger waves of star formation as gas clouds compress under tidal forces. Massive, short-lived stars will blaze into existence, illuminating the merging arms. Supernovae will flash like cosmic fireworks, spreading heavy elements through the new galaxy. These bursts of creation will fade over time, leaving behind a calmer, more stable structure. The Milky Way and Andromeda will have become the latest expression of the universe's endless cycle of union and transformation. For us, the timescale is beyond human reach, yet the knowledge itself is humbling. To know that our galaxy moves toward another, that we are part of a grand ongoing process, reshapes our understanding of permanence. Nothing in the cosmos is static. Every structure from atom to galaxy exists in transition. The beauty lies not in the illusion of stillness, but in the grace of motion, in the quiet inevitability of change. Perhaps the universe is not merely expanding, but evolving toward harmony. Each merger brings systems into deeper balance, redistributing mass and energy, forging order from motion. The collision of the Milky Way and Andromeda is one small movement in this greater symphony, a chord that will resonate for eons. And when the merging is done, when the last streams of stars settle into new orbits and the new galactic core glows steady in the dark, the cosmos will remain vast, peaceful, and continuing. For beyond Milkomeda, countless other galaxies will still turn drift and draw together, following the same timeless rhythm. So as you drift now in thought, imagine that future night sky, the arcs of light across the horizon, the twin spirals entwined. Imagine the silence of two galaxies meeting not in violence, but in embrace. The same gravity that binds your feet to the earth binds the stars together. The same laws that shape galaxies shape your own existence. And beyond this union, something greater awaits, a vision of the universe itself, not as separate galaxies, but as one bound web of light. For after the merger comes perspective, the realization that every galaxy, every star, every atom is part of one infinite whole. Beyond the Milky Way, beyond Andromeda, beyond even the future galaxy, they will one day form. There stretches a structure so vast, so intricate, that even our largest telescopes can glimpse only fragments of it. It is the grand architecture of the cosmos, the cosmic web. This web is not woven of light. but of gravity, dark matter, and time. It connects every galaxy, every cluster, every atom in existence into one continuous tapestry, reaching across tens of billions of light years. The galaxies we see are merely the bright knots where the strands of this invisible network meet. To understand it is to see the true shape of the universe. In the beginning, the cosmos was almost perfectly uniform, a smooth sea of hydrogen and helium left behind by the Big Bang. But in that early stillness, there were tiny fluctuations, minute variations in density, 1 part in 100,000. Over billions of years, gravity amplified those differences, pulling matter into denser regions. The first galaxies formed where these ripples converged, and as they grew, they linked together into filaments, forming a vast, three-dimensional web. Between these filaments lie immense voids, regions so empty that across hundreds of millions of light-years only a handful of galaxies exist. Today, we can see this structure mapped in surveys like the Sloan Digital Sky Survey and the Dark Energy Spectroscopic Instrument DESI project. They have charted millions of galaxies, revealing patterns that look like a cosmic brain, filaments branching and connecting like neurons, clusters glowing where the filaments intersect. Each bright node is a galaxy cluster containing thousands of galaxies, and each filament is a river of dark matter and gas that feeds them. The scale is almost incomprehensible. The largest of these structures, the Hercules, Corona Borealis Great Wall, spans more than 10 billion light-years, the largest known feature in the observable universe. Our Milky Way belongs to a small cluster of galaxies called the Local Group, which includes Andromeda, the Triangulum galaxy, and about 50 dwarf companions. The Local Group itself is part of a larger supercluster known as Laniakea, a Hawaiian word meaning immeasurable heaven. This vast region stretches 500 million light-years across and contains around 100,000 galaxies. In this immense landscape, the Milky Way and Andromeda are tiny, two small eddies in a much larger cosmic flow. Laniakea is not an island. It too drifts within an even greater gravitational landscape, drawn toward regions of higher density pulled by the Great Attractor, a mysterious center of mass hidden behind the plane of our own galaxy. Beyond that lies another vast concentration of galaxies, known as the Shapley supercluster, the most massive structure in our local universe. The Milky Way, like a leaf in a gentle current, moves toward these invisible centers, carried by the expansion and curvature of space-time. And yet, even these immense structures are only part of the visible universe. Beyond them lies the cosmic horizon, the limit of what light has had time to reach us since the beginning. The observable universe extends for about 46 billion light-years in every direction. Beyond that space continues perhaps infinitely. In that sense, the web of galaxies we can see is only a tiny patch of something far larger, an endless ocean of structure and silence. What binds this web together is gravity, not only from visible matter, but primarily from dark matter. The same invisible substance that shapes our Milky Way's halo also sculpts the universe itself. Dark matter filaments act as scaffolding, guiding the flow of gas and the formation of galaxies. Without it, the cosmic web would never have formed. The universe would remain smooth, featureless, and dark. In this way, dark matter is the framework of creation, the silent geometry beneath the visible cosmos. But there is another force at work, a force that pushes outward, opposing gravity's pull. It is known as dark energy, a mysterious pressure that accelerates the expansion of the universe. Discovered in the late 20th century through observations of distant supernovae, dark energy makes up about 70% of the total energy content of the cosmos. Its effect is subtle but relentless. Over time, it stretches space itself, carrying galaxies farther apart. The cosmic web, though vast and connected, is slowly being pulled thin. In the far future, distant galaxies will drift beyond our horizon, their light stretched to invisibility by expansion. And yet here and now the universe is in perfect balance. Gravity gathers, dark energy expands. Between these two forces, structure emerges, not chaos, but pattern. Every galaxy, every star, every planet is a result of this balance. The cosmic web is the visible expression of harmony between attraction and release. When astronomers look out across this web, they do not see random scattering, but order filaments that echo the mathematics of turbulence clustering that follows fractal rules. The same equations that describe the growth of trees, the branching of rivers, and the flow of air also describe the universe's shape. In this way, the cosmos repeats itself across scales, galaxies forming like droplets in a cloud, superclusters branching like coral in a sea of time. The light that reaches us from these distant structures carries the story of the universe itself. The faint glow of the cosmic microwave background, discovered in 1965, is the oldest light we can see radiation left from when the universe was only 380,000 years old. It is a map of the first ripples that would one day become galaxies. Each pixel in that faint radiation field marks the seed of a future cluster, the first notes of the symphony that would become the cosmic web. The more we learn about this structure, the more we realize how deeply interconnected everything is. The Milky Way's position, its shape, its motion, all are determined by the gravitational flow of the web. The atoms in your body once drifted through those filaments long before they were part of any star or planet. The air you breathe and the light that falls upon your skin are both shaped by forces that began in those earliest cosmic ripples. We are not separate from the web, we are woven into it. From this perspective, even the most distant galaxies are not foreign, but kin. Each one follows the same physical laws, the same gravitational rhythms, the same cycles of birth and dissolution. Every flicker of light, every echo of radio wave, every particle of dust belongs to the same universal structure, one that grows, changes, and endures. And yet as we map more of this web, we find something humbling. There is no center. The universe has no preferred direction, no privileged place. Every point is equivalent. Every galaxy sees itself surrounded by others. The cosmic web extends endlessly with no boundary, no edge. The Milky Way is not at the center. It is simply one node among countless others, drifting in infinite space. This realization does not diminish us. It completes us. We are part of a pattern so vast that it cannot be contained, yet so precise that every law holds true across billions of light years. In the silence between galaxies, there is motion. In the emptiness between filaments, there is potential. The universe is not still. It is expanding, evolving, and unfolding like a great flower blooming in slow time. To see the cosmic web is to glimpse the framework of existence itself, the skeleton of infinity shimmering with light and shadow. And as you breathe now, imagine drifting far beyond the Milky Way, past Andromeda, past Laniakea, until the galaxies form threads of light beneath you. See how they connect, delicate, radiant, endless. Feel the gravity that binds them, the expansion that carries them apart. Between these forces lies everything we know, everything we are, and everything that will ever be. In this vastness, the mind grows quiet. The scale is too large for fear, too beautiful for comprehension. We are each of us brief flickers of awareness within an infinite web, the universe contemplating itself for a moment before returning to silence. But the journey does not end here. For beyond this comprehension, beyond the cosmic web, lies reflection, the return home not to a place, but to understanding. The story of the Milky Way of light and darkness, of stars and silence, finds its meaning not only in space, but in consciousness. For when we finally see how infinite the universe is, we also see how perfectly we belong within it. Now, after drifting through the heart of our galaxy, through its luminous arms and dark matter halo, through its slow breath of stars and mergers and beyond it, into the filaments of the cosmic web itself, we return not to the beginning but to a quieter awareness of where we are. The Milky Way is no longer just a streak of pale light in the night sky. It is a home, a vast dynamic system that has given birth to stars, to planets, and to the consciousness now reflecting upon it. Every atom of your body has journeyed through this galactic cycle. The calcium in your bones was forged in a dying star. The carbon in your breath was once part of a nebula drifting through the spiral arms. The iron in your blood was created in the heart of a supernova. The hydrogen that forms the water within you has existed since the first moments after the Big Bang, the same hydrogen that fills the galaxy's clouds today. You are not separate from the Milky Way. You are its expression, its continuation, its awareness made visible for a fleeting moment. When astronomers look at the Milky Way, they see it from a position of both intimacy and distance. We are inside it, carried by its rotation, bound by its gravity, part of its substance. And yet through light and mathematics, we have stepped outside it, in understanding, able to map its shape and measure its motion. This duality, to belong and to observe, is the hallmark of intelligence. The galaxy has, through billions of years of transformation, evolved eyes with which to see itself. The awareness of this unity brings a stillness that words can barely hold. Every star, every cloud, every orbit and explosion, all of it has led step by step to this single moment of recognition. You, a small being on a small planet in one corner of a spiral arm, are part of a continuity that began long before life existed and will continue long after the last star has faded. The Milky Way is not a place you live in. It is something you are made of. As the night sky stretches above you, that faint band of light, the Milky Way's disk, seen from within, is your horizon of memory. Those stars are family. Their light, traveling for thousands of years, enters your eyes tonight as a quiet echo of creation. Some of them are gone already, their brilliance now only a message from the past. Others are newly born, their light just beginning its long voyage through time. In every direction you are surrounded by history written in photons. And beyond the Milky Way, there is more, not just more galaxies, but more of everything. More matter, more light, more gravity, more time. The cosmic web is not a boundary, but an invitation. The universe is expanding, carrying the galaxies apart like notes in a melody that never repeats. Yet through all of this, the laws remain the same. The physics that govern the stars also govern your heartbeat. The same gravitational pull that holds galaxies together keeps the oceans at the shore. The same thermodynamic principles that ignite suns fuel the warmth of living cells. The same entropy that drives the universe forward shapes the cycles of your own life. To see yourself as a citizen of infinity is to recognize that you belong not to a single planet or star, but to the entire universe. You are a part of its history, a participant in its transformation. You are bound to the galaxies through the laws of nature and to the stars through shared matter. And though your lifetime is brief compared to the ages of galaxies, your awareness, this moment of knowing, connects you directly to all of time. There is a humility in this understanding, but also a peace. The universe does not ask to be worshipped, only understood. It is indifferent to our smallness, yet generous. In what it gives us light life and the capacity to wonder. To gaze at the Milky Way is to look into a mirror, not of glass, but of existence. What you see there is what you are. And now, as your thoughts settle like starlight on calm water, imagine the galaxy again. See its spiral arms glowing softly in the dark. See the stars drifting, orbiting, shining, fading. Hear in the quiet of your own breath the slow rhythm of the Milky Way's rotation. The galaxy turns. You breathe. The galaxy evolves. You change. The galaxy endures. So too does the pattern of life that comes from it. Even after the Milky Way merges with Andromeda, even after new galaxies form, and old ones fade, this pattern, this quiet continuity will remain. Matter will flow from one form to another, light will continue to travel, and somewhere consciousness will arise again to observe it. The story of the universe is not one of endings, but of endless becoming. The night sky is a reminder of that continuity. Each star you see is a moment in that unfolding, a note in the universal symphony. To fall asleep beneath it is to rest within the rhythm of creation, the same rhythm that moves galaxies and dreams alike. So breathe slowly. Let your thoughts drift outward, past the boundaries of the world, past the edges of the Milky Way, into the stillness between galaxies. Feel the peace of vastness, the calm of connection, the quiet hum of being part of something infinite. For in truth, you have never been small. You have only ever been a brief, beautiful reflection of the universe. The Milky Way made conscious, resting for a moment beneath its own stars. And now, as the cosmos turns softly on its endless course, may your thoughts drift among the galaxies, weightless and serene, carried on the quiet current of time. Good night, traveler of the infinite sky.